the late 80s, we were supplying hydraulics for the thruster systems on the bow and the stern of the vessels. It was great business for us, but as technology began to change, we saw a threat because of variable frequency drives and electric motors were being talked about. I'm Chuck Moorhead. I'm owner and CEO of Gulf Coast Air and Hydraulics located in Mobile, Alabama. We are a marine and industrial solutions company, and we set up systems and we collaborate with ABB on service and sales. When Master Boats came to us and they had an opportunity, they were going to do a vessel that had electric thrusters on them, they asked us if we were willing to get on board and learn the new technology, and we said, sure, we'd love to. The greatest benefit of the electrical thrusters is the ability to interface with the dynamic positioning system on these vessels. And using an electronic, we were able to interface and take a lot of the equipment that could break down between the mechanical thruster and the software of the dynamic positioning system.
DP2, you have to have a minimum of 2 thrusters in the bow and 1 in the stern, and split rudder. These vessels out here have 2 in the bow, 2 in the stern, and split rudders. So really, if we had a loss in the stern, we could actually have what you could have double redundancies and still hold station. My name is Andre DeBrock. I'm with Master Boat Builders, General Manager. We build just about anything that floats, starting off with fishing boats, then to small offshore supply vessels, mid-90s. Went back to combination of fishing vessels and supply boats, and strictly supply boats 2000 until today. Running these engines at high speeds and while you're DPing that next to a rig is very loud, very noisy. So we started looking at the concept of how we could do this without the noise. We first tried hydraulics, still noisy. That's where we started looking at the possibility of going to different drives, VFDs, and see what we could do to make it work.
They want to use our setup because it's quiet. You don't want to hear your thruster moving back and forth. Being able to interface back to dynamic positioning, the ABB drives and motors react much quicker than the hydraulics ever did. They break quicker than the hydraulics ever did. So it's just a better setup. It's more efficient, it's cleaner, it's a better way of doing it. You know, the ABB drive is perfect for the marine industry in that their drives are built modularly. So when they hit that dock, if they have a problem with an ABB drive, you don't have to climb in the cabinet and start taking parts out. You pull the module out, you replace it with your spare module, you plug it back in, you turn it on, and you're ready to go. I don't think there's anybody else in the industry that can do that.
The controls have definitely evolved over the drives. We've done it several different ways, and we're at a very good set of system that, as of right now, we're utilizing. As far as ABB, engineering support, we've never had an issue where we needed help that we didn't get it.
You know, because it was new technology, the shipyard was ignorant to it. I was ignorant to it to begin with. ABB came in and did a great job of making everyone feel comfortable about what we were installing, how it would interface, and how it would operate on our first sea trials. And since we've been with the ABB product, about 90% of our issues have gone away. The good thing about ABB is, though, we have very few warranty calls. In 10 years, I can only really think of 3 warranty calls that we've had, period. When you're operating that electric motor in the worst conditions possible 24 hours a day, the thrusters never turn off.